Welcome to ClickMyProject.com. Now we are going to discuss about the project Compressive Wavelet Domain Deep CNN for Image Classification using Genetic Algorithm Based Sensing Mask Learning. Now we are going to discuss about the abstract of the process. Animal detection and recognition based on the image processing is the wild concentrating field in the research. To better understand the complexity of natural ecosystems and to manage and protect them, it is necessary to classify the species of the animals by using the digital image processing. The motivation of the project is to build an automatic system for detection and recognizing the species of the animals for the animal researchers. Hence, in this process is developed based on the digital image processing in Python. So, in this process, the domestic animal is considered as an machine learning techniques algorithm implemented for the animal recognition systems. The detailed research were developed, they carried out using the low individual features and then perform the combined features. Hence, the features are extracted from the images based on the low individuals as well as the combined features. The algorithm is implement and generate the results based on the performance metrics like the accuracy, precision, recall and F measures. So based on these three parameters, we can justify our processes efficiency. On the other hand, we have three criteria of these steps to handle this project like feature extraction, classification and performance estimation. Based on these three steps only, the process will be undergone to complete the overall project. Now we are going to discuss about the overall working flow of this project. These are the overall working flow of this project. This project consists the modules such as the input image, pre-processing, feature extraction, feature splitting, classification, then finally performance estimation. At first, the input image is taken from the dataset. The dataset consists of the several kinds of the animal images. After taking any one image from the dataset, the pre-processing will be carried out. In this pre-processing, the image resize is carried out to set the dimension of the image. So hence in this process we have using the 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After doing the image resize, we just move to the feature extraction. In this feature extraction, the feature extraction is nothing but this to collecting the data from the images. Here the pattern kind of feature is extracted from the images. After extracting the features from the images, those features are called as the test features, which is extracted from the input image alone. After doing the feature extraction, feature splitting will be carried out. In this feature splitting, we have considered as two major things. One is the test feature and then the train feature. So the test feature consists the features of the input images, hence the train features consist the features of the overall images. For example, we have a lot of images in the dataset. We have considered the lot of training sets in the background features, hence the foreground features will be the input image features. Those foreground features will be the test features. After the splitting of the features, we just move to the classification. In this classification, we are using the machine learning techniques to classify the species of the animal. In case of the species of animal is recognized as the species 1, in the sense it will be displayed the result as species 1. Likewise, it will classify the each and every species in the dataset. After doing this classification, we just do the performance estimation. In this performance estimation, we are estimating the performance like accuracy, sensitivity and specificity based on the parameters like true positive, true negative, false positive and false negative. Now we are going to discuss about the running procedure of the process. At first, open the Spider 3.7. After that, we have to change the current directory. If you want to execute the file, just open the main file.py and then select the option run. After doing the selection of the run, the dataset will be open. In that dataset, you can see the several type of dog images. So we have several species of animals. So we have to select any one species from the dataset. After selecting the image from the dataset, the corresponding image is processing, and then the results were shown in the console. So now we can see the results one by one. At first, this is the input original image we have taken from the dataset. So after taking the original image from the dataset, the channel separations will be carried out along with the image resize. So you can see the difference between the resized image and then the before resized input image. So the image size is around 500 something. So here, after doing the image resize, the image is resized into particular ratios of 256. So after doing the image resize, the image is channel separated by means of the red, green and blue channel separately. After converting the red, green, blue channel separately, we have to separate the grayscale conversions. Here you can see the results of the grayscale conversion. After doing the grayscale conversion, everything, we have to do the segmentation as well as the deep learning method to train test data splitting. Here you can see the percentage of splitting for test alone. Here the train data splitting. So here the test data is splitted as an 20% and then the train data is splitted as an 80%. Overall data set is 100%. After doing the data splitting everything, we just doing the feature extraction. In this feature extraction, the local binary pattern is applied to extract the features from the images. After doing the feature extraction, these are the values represents the feature values. Once the feature extraction was completed, we just move to the classification stage. In this classification step, the recognized result will be displayed here. After doing the classification everything, we just move to the final stage of the project, that is the classification accuracy. So here the accuracy of the classification is around 99.3% and then the error rate is around 0.6%.